Everybody, here we are, 8.2 properties of chords in a circle. First the definition, and then I'll go over the properties. In a way, the properties are all going to kind of feel the same, but they do kind of suggest something a little bit different. But, it looks like a lot, but it's kind of all the same idea. So just a short definition first, and I put yours on there, which is that what a chord is. A line segment that joins 2 points on a circle is a chord. So if I have a circle, a line that connects 2 points, that's a chord. And the diameter is just a special kind of chord. It goes through the center of the circle. So the diameter is a chord, but not all chords are the diameter. So a chord doesn't need to pass through the center, but it's a line segment that joins 2 points on a circle. A diameter is a kind of chord. So let's look at property number 1, and I think you'll see why they kind of feel the same, but each of these is saying something slightly different. So the perpendicular from the center of a circle to a chord bisects the chord. So a couple pieces of information. Perpendicular, remember, are two lines that intersect each other at 90-degree angles. And this word bisects, look at the, we talked about this with our polynomial. Bi means 2. So it splits our line in 2 equal parts. So you can see here we have a little line right here and a little line right here to show you that these 2 segments are equal. And so this is saying perpendicular from the center of the circle to a chord bisects that chord. So a line that goes from the center of the circle and is perpendicular to the chord is going to cut it, is going to slice it into 2 equal parts. That is, the perpendicular divides the chord into 2 equal parts. There you go. So point O is the center of the circle. When OCB equals OCA equals 90 degrees, then AC is equal to CB. Okay, so really, I think all of this info is kind of contained in the other parts, but let's move on. So property number 2, the perpendicular bisector of a chord in a circle passes through the center. So I guess we're kind of working in reverse here. We're saying that if we started, let's say, with this chord, and we were able to bisect it perfectly, then that line would pass through the center. So in our first one, we're kind of going from the center perpendicular downwards, and that's bisecting the chord. Here we're saying we have a chord, we were able to bisect it perfectly, that perpendicular line would pass through the center. So feels kind of the same, but a little bit of a reverse. So when angle SRP equals angle SRQ, they both equal 90 degrees. And PR, this side here, equals RQ, that side there. Then the bisecting line passes through the center. Okay, kind of feels the same, looks the same, but slightly different info. And this last one looks the same, a line that joins the center of a circle and midpoint of a chord is perpendicular to the chord, which we've kind of been talking about, which means when O of the center of the circle and this length equals this length, then the angles are going to equal 90 degrees. So that's saying that if this bisects this perfectly, these 2 angles are going to be 90-degree angles. So hard in a way to see the distinction, but I included all the properties nevertheless. What we need to know is that a line that is perpendicular to the chord passing through it passes through the center, makes 2 90-degree angles, and it splits the chord perfectly in equal parts. So let's do the first one. Point O is the center of the circle. Okay. And determine the values of X and Y. So here's what we know. We got the center of the circle. It is bisecting this chord into 2 equal parts. So what we can assume from that is that if it passes through the center and bisects a chord into two equal parts, that it does so, it's perpendicular, and it does so at a 90-degree angle. So we know that x is going to equal 90 degrees because we have a line that passes through the center and bisects a chord into two equal parts. Therefore, it's perpendicular, and that angle is 90. And then what else do we know? We know that the angles inside a triangle equal 180. So we have 180 minus the 90 we just found, minus the 48, and that's going to equal our y. And I'm pretty sure that's just 52, but let's do it in your calculator. Let's do 180 minus 90 minus 48 equals, 42 degrees. Okay, I'm wrong. There we go, 42 degrees. Good. Y equals 42 degrees. Of course, actually, that makes sense. And there you have it. That's why you check. Okay. So does that make sense? Yes, it does. 45 plus 45 is 90. That's why, there we go. We're looking for these two to equal 90 degrees. That makes sense, not 52. Let's look at the next one. Point O is the center of the circle. Okay, and it's telling us that OF equals 18 centimeters. Okay, so we know this like radius is 18 centimeters. And because this is a chord that passes through the center, I know it's the diameter. So we can also assume that this other side is 18 centimeters. Okay, and what else? We have GJ. So this whole thing right here, GJ equals 14 centimeters. Determine the values of x and y to the nearest tenth of a centimeter where necessary. So what do we see here? Let's investigate for a second. So we see here that this line passes through the center and meets at a 90-degree angle. So what we can assume from that is that it bisects this chord. And we can assume from that that this side right here is equal to this side right here. So if the whole thing is 14 centimeters, then x equals 7 centimeters. So I don't know, we want to show that this whole thing is 14, therefore that's 7 centimeters, and that right there is 7 centimeters as well. Okay, because together they make 14 centimeters. And because this meets at a 90-degree angle, we know that it is perpendicular, therefore it bisects the chord and splits that into two equal parts. And now what else can we do? We have that this part, kind of the hypotenuse of our triangle, the longest side and the side that's adjacent to our 90-degree angle is 18, and one of our legs is 7. So we also know that 7 squared plus y squared, that's what we don't know, equals 18 squared. So let's do that. 7 squared is 49 plus y squared equals, what's 18 squared? 324 or something like that. Yeah, 324. Now we can get our y by itself. Let's minus 49 from each side. We get that y squared equals minus 49 equals 275. And our last step is to do the inverse operation of squaring, which is taking the square root. That cancels that out, and we get that y is going to equal the square root of 275, which is 16.6. So y equals 16.6 centimeters. And the last thing we should do is ask ourselves, does that make sense? Yes, I would say that does make sense. We got 18 needs to be the longest side. That's longer than 16.6. It's a little bit longer than 7. I would say that makes sense. Okay, let's do our last question. We need to do a little bit of drawing to figure out what it's asking. So we have number one, a circle has a diameter of 70 centimeters. So let's draw that. Diameter passes through this special chord that passes through the center. It's 70 centimeters. Okay, a chord in the circle is 50 centimeters long, so probably going to be like about there, and that's 50 centimeters. Okay. How far is the chord from the center of the circle? Give the answer to the nearest diameter, or centimeter, sorry. So if we were to draw a line perfectly there, it would bisect these two sections and make a 90-degree angle. So we would split that into a side that's 25 centimeters. And this is what we want to find out. We want to know how far is this chord from the center of our circle. So how do we find the other length? Well, we can make another dot that goes from our center to the outside of the circle. We can make a radius, and we know the radius is half of the diameter, so we know that's going to be 35 centimeters. Okay, so now we have the hypotenuse, we have a leg, and we need to find the other leg. So we have this information that 25 squared plus, let's say, b squared equals 35 squared. So let's solve that. 25 squared, 625 plus b squared equals 35 squared. 1225. Now let's minus 625 from each side. Ooh, 25. To get that b squared by itself. So now we have b squared equals 1225 minus 625 equals 600. And now our last step, we want to do the inverse operation. We can take the square root. That cancels that out. And we're left with b will equal the square root of 600, which is 24.5. So b equals 24.5 centimeters. Does that make sense? Yeah, I would say that it does. It's a little bit shorter than the radius, or sorry, it's smaller than our radius. Certainly, that needs to be our longest side. It's a little, maybe this could have my drawing might not have been the best, but I would say that it makes sense. It's pretty close to I think what we would like, and we want our 35 to be the longest. That's good. I think I'll tell you the textbook questions that I want you to do, though. I do want to, maybe I should spend a moment, and maybe I should have done this last time, to explain why having something squared and taking the square root cancels it out. So say, let's just, for example, let's do a quick detour. We have 4 squared, and we also have the square root of that. So what 4 squared is, so if we have the square root of 16, that's 4 squared. The square root of 16 equals 4. So you can see that these two operations cancel each other out. So that's why we do that step. We do the inverse operation to get rid of that those things always cancel each other out. So maybe, hopefully that explains it if you don't remember from grade 8, but those things cancel each other out, that the square root of 4 squared is just 4. Okay, thank you so much. I'll let you know what textbook questions I'd like you to do.